Monday, we spent some time learning how to add vectors in 2 dimensions. Okay? We learned in grade 6, grade 7 to add vectors in 1 dimension. 3 plus 4 might have been 7. 3 plus 4 might have equaled -1 if the 4 was in the opposite direction or a negative value, right? We know how to do that. Okay, doesn't take a rocket scientist to add these numbers together. It takes somebody who's familiar with grade 7 math to do this. But what if the 3 and the 4 weren't on one plane? What if they weren't both on the x-axis or both on the y-axis? What if we couldn't say 3 plus -4 is equal to 1, but rather we had to say 3 on one axis and 4 on the next axis, the other axis, is equal to something? How would we go about solving for that something? Well, remember, the goal here is to get a right-angled triangle. That's always the goal. Even the questions you see at the bottom of the worksheet that I gave you yesterday, those crazy angled questions, the goal is still to get a right-angled triangle. Right now, we have a right-angled triangle for this one, and it comes from drawing a vector diagram with both of the vectors involved. Okay, we had 3 to the right. All right, draw a vector, 3 to the right. We had 4 up. All right, draw 4 up. Make sure you draw them front to back. That's exactly what we did here. 3 to the right, front, 4 up, front against back. We could have also drawn that, by the way, this way. 4 and then 3, that still would have been drawn front to back, and all the rules of vector addition would still be met here. The resultant vector, sometimes we call it R for the resultant vector, sometimes we call it C. Where would C come from? Why are we calling it C? Tyson, was your hand up there? No? Mackenzie? Yeah, good. And when we do the Pythagorean theorem, the hypotenuse is usually call it C, right? A squared plus B squared is equal to C squared. So we can call that C if we want. Okay, we know how to find the value of that C. We're going to say C squared is equal to A squared plus B squared. Or C is equal to the square root of that. Ends up being equal to 5. Same deal over here. C would be equal to square root of 4 squared plus 3 squared, which equals 5. We're not done, though. We need something else here, right? When we're adding vectors together, it's not good enough just to get a magnitude. We also need a direction. How are we going to express the direction here? Remember, adding these vectors together, we express direction by positive or negative. Can't do that here. How do we express direction for these ones? Cody? Yeah, good. It's degrees. It's an angle, right? The angle that you draw or that you measure is always the angle at the start. Okay, some people are like, oh, is it this angle? Is it this angle? It's always the angle at the start. So right here or right here. We're going to find that angle by trigonometry, right? Remember, so, ka, toa. We have opposite and adjacent. Let's use toa. Let's use tan, or because we're looking for the angle, let's use the inverse tan, or the second function tan of 4 over 3. This one would be the inverse tan of 3 over 4. We do that, we get 53 degrees right here. If we do this one, by the way, we're going to get 37 degrees, right? We would express this one as 53 degrees something of something. 53 degrees something from something. Mackenzie? Good. 53 degrees north of east. Why? Because it's measured from the east axis. Measured of the east axis, from east. Okay? But it's going north from east. North from east or north of east. This one would be measured from the north axis, right? So this one would be something of north. Of north, from north. Where did we go from the north here? East. So it would be east from north, or east of north. Does that make sense? Good. Good. Let me do one more little thing with you, and then we'll take a look at a couple questions that we had on that worksheet. Let's say we got another one that's, say we got 1 meter to the north. Then we walked, let's say, 3 meters to the west, and then we walked another 2 meters to the north. How do we tackle that? Well, we draw a vector diagram. We got 1 meter to the north, looks like this. We got 3 meters to the west, looks like this. And then we have 2 meters to the north, looks like this. The resultant vector goes from start to finish. What's the goal? What's the goal in all of these problems? It's a pretty simple goal. It's not always easy to get to, but it's a pretty simple goal. We always want to get a right angle triangle. It's not what we got here for sure. It's not even a triangle, let alone a right angle triangle. Yeah?
We did 2 equations and just added up what we come up with that word.
If you did 2 equations and add up what you got? Oh, so you mean find this one and find this one?
Yeah.
Okay. Theoretically, that's okay. Your problem with that in practice is you don't know what this side is or what this side is. Right? That whole thing, right, along here is 3 meters, but where does this resultant vector intersect it? Okay? If you knew this part and you knew this part, then you could find the hypotenuse here and find that hypotenuse and add them together. Absolutely. Okay, but in practice, we don't know what those two numbers are. Okay, good thought. It's a good thought. What are we going to do here? Remember what we said? Break it up into x and y. Let's add up all the x's here. How much of the first one, okay, that 1 meter is x component? Remember, x is this way, y is this way. How much of the first one is x? 0. Good. How much of it's y? Good. So none of it's x, all of it's y, right? 1 meter. How much of the 3 meters is x? How much of the 3 meters is x, Caitlin? 3? Close. Yeah. Let's make it -3 because it's to the left, right? Well, how much of that is y component? None, right? None of it. How much of that 2 meters is on the x-axis? Sorry. Cassie, how much of that 2 meters is on the x-axis? Good. How much of it's on the y-axis? Fernanda, how much of that's on the y-axis there, that 2 meters? Can't see it? Two meters, or all of it, right? Add these up. 0 plus -3 plus 0 is -3. 1 plus 2 is 3 meters. Oh, this is good news. Wait a second. Yeah, this is good news. Why is this good news? -3 plus 3, right? Front to back, front to back. -3 plus 3 gives me this vector. We're going to call it C, the hypotenuse. It's good news because what's the angle work out to be there when we've got 3 and 3? Same two sides, opposite and adjacent. 45 degrees. The inverse tan of opposite over adjacent would be 45 degrees. This would be north of west. Measure from the west, but north from the west. C, or the hypotenuse, is going to be square root of 3 squared plus 3 squared. How is this different than this? Well, in the end, goal is to get a right angle triangle, right? That's the same. This one, we got a right angle triangle right away. In this one, we had some kind of crazy shape right away that we had to turn into a right angle triangle by doing x and y components. So this is what's different about it. This little bit right here. Once we get this, it's exactly the same as that last question. Got your right angle triangle, do the Pythagorean theorem, do the inverse tan function. Got it? You guys worked on a worksheet yesterday, questions 1 to 5. I want to go over number 5 here. Number 5 said add these vectors together. We had 8 down. Good news is the vector diagram was already drawn for you. We had 8 down. Then we had 12 to the right. That's drawn front to back, so it's okay, right? So far the rules have been followed here. We've got 10 up, or 10 to the north. And then we've got 4 to the west. Are all the rules met here? Did I follow all the rules when I drew this diagram? Yeah, they're all drawn front to back. Didn't matter what order I drew them in, right? I could have completely reversed them, would have been fine. The resultant vector is drawn start to finish right here. I'm not even going to call that C right now, because C kind of infers that it's the hypotenuse of a triangle, and that isn't a triangle. I don't know what shape that is. It's not a triangle. What's the goal? What's the goal, Kelly? Get a triangle, get a right angle triangle. If we don't have it, we got to get it by doing this. How much of the first vector, Nick, is x component? Remember, x is this way, and y is this way. How much of it's x?
0.
Good. How much of the first vector is y component, Sadie? Good. -8. Excellent. Not just 8, but negative because it's downward. What about the second one, this 12 meters? How much of that one is x component? Stephen? How much of that 12 is x component? 12? Yeah, good. How much of it's y component? Zach? 0, good. 10 meters. Notice how much of that 10 meters is x?
0.
Good. How much of it's y? Notice how much of it's y?
10.
Good. Cassie, how much of that 4 meters is x? Sorry. Sorry, I was looking at Katie and calling her Cassie. I meant Katie. Sorry, Cassie. Sorry? Good. Cassie, I think I already nailed you for a question already, didn't I? Yeah. And how much of it's, now I'm thinking Cassie. Katie, how much of it's y? Good. 0, 12, -4 gives me 8. -8, 10 gives me 2. And we could draw this in one of 2 ways. We got 8 to the right, 2 up. Or you could go 2 up, then 8 to the right. Both would be correct, right? How do we know neither of them are, how do we know the 8's not to the left or the 2's not downward? Yep. They're both positive, right? If it's supposed to be down or left, then we'll get a negative. Now we can label that C, because it's the hypotenuse of a right angle triangle. Theta goes at the start of that triangle. C is equal to the square root of 2 squared plus 8 squared. And theta is equal to the inverse tan function of opposite over adjacent. Ethan, what's the opposite side of that triangle? 8 or 2? 2, good. And the adjacent side's 8. Mackenzie, what did you get there? Sorry? 14 degrees for this one? Okay, so you guys are supposed to be finding this one, right? Your side? 8.0? It should be 8 point something. 8.2? And this was 14 degrees? And this would be 14 degrees what of what? Our vectors are east and north, right? So it's going to be east of north or north of east. Which one is it? North of east, because the angle is not measured from the north. It's measured from the east, right? There's our east vector measured from the east. So north of east. North from east or north of east. Is that good? I want to go a step further with this now, okay? Now I want to find vector components with funny angles. I don't see any funny angles here yet, but I kind of want to lead you into it. Remember, this is your XY plane. Everything this way is X. Everything this way is Y. Got to remember that. Okay, that's important. Let's just do a quick little review. Some of the stuff we've already covered here. How much of these are X and how much are Y? 10 meters? All of it is X. How much is Y? 0. Good. How much of the 200 meters is X? And how much of it's Y? 200 meters. How much of this 50, Sabina, how much of this 50 is X? Close. Not 50, but real close. About negative 50? Because it's to the left, right? How much of it's Y? Be 0 with it. How much of the 35 is X? 0. How much of the 35 is Y? Good. Good. Nothing new there yet. We don't have any funny angles. What do I mean by a funny angle? I mean something like this. How much of that 100 meters is X? How much of that 100 meters is Y? How much of that 20 meters is X? How much of that 20 meters is Y? When I see, listen carefully. When I see a funny angle like this, and a funny angle I mean is 30 degrees, 60 degrees, 27 degrees, 91 degrees, something other than 90 degrees. Okay, if it's not straight across or straight up or down, then it's a funny angle. I want you to think of 5 words every time you see a funny angle. It doesn't matter whether it's in this context or whether it's like what we did in Physics 30 this morning. In Physics 30 this morning, when you're talking about electric forces, the 5 words you should think of when you see a funny angle are, I don't like funny angles. I don't like funny angles. Simple as that. You got an angle of 30 degrees? I don't like it. I don't like funny angles. So get rid of it. Here's what I want you to do when you see funny angles. Because you don't like it, let's get rid of it. Let's turn it into a little triangle. This would be the X part of that triangle, and this would be the Y part. This would be the X part, this would be the Y part. We need to get rid of the 100 meters at 30 degrees. We need to turn it into this and this, because we're comfortable with that, right? Look at the last sheet, hey? You guys nailed that. That was easy. So turn this into this and this. How are we going to figure out how much of that is X? How are we going to figure out how big that side of the triangle is? Goes? Yeah, good. SOHCAHTOA. Let's write that down just to remind you about what's what here. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tan is opposite over adjacent. The X component of this is which side? Opposite or adjacent? Or hypotenuse? No? The X side is the X is right beside the angle, right? Cody, it's the, good, it's the adjacent side. So if we're looking for adjacent and we have hypotenuse, let's use cos. Cosine 30 degrees is equal to adjacent over hypotenuse. Do that math, it works out to be 86.6 meters. The Y component must therefore be the opposite side, right? Opposite to the angle. Opposite in hypotenuse is sine. So Y ends up being equal to 50 meters then. So what we've effectively just done is taken a vector, 100 meters at 30 degrees, and we've turned it into 2 vectors. We had 1 vector. Now we've got this, and we've got this. And we know how to deal with those, right? We know what to do with those. What are the 5 words you should think of when you see a question involving a funny angle? I don't like funny angles. So get rid of it. Turn it into something you're comfortable with. turn this into this. All right, let's finish off this one too, okay? X side, opposite or adjacent, or hypotenuse? Yeah, it's opposite. So opposite and hypotenuse, right? Opposite and hypotenuse is sine. We're going to say sine 30 degrees this time is equal to x over 100, over 20, isn't it? X ends up being equal to 17.32 or 17.33. Cosine 30 degrees is equal to, no, that's not right. Should be 10, shouldn't it? Is that right? Yeah, 20 sine 30 is 10. Cosine 30 degrees is equal to adjacent, which is the y component this time, over 20. Y is going to be equal to 17.32 or 17.33. What have we done? We just got rid of that 20 meters. Listen, once we do that, we never have to deal with it again. It's gone. We just turn it into something we can deal with. We turn it into 10 meters and 17.3 meters down. I can deal with that. I can deal with that. Did that Monday. Did that pretty much the rest of today's class. That's not hard. It's a funny angle that's hard, so get rid of it. If you can take a look at your worksheet, please, from yesterday, I'd like you to work on questions 6 through 13 on that worksheet right now. Don't go to 14. Okay, stop at 13. 6 through 13. You're going to see that questions 6, 7, and 8 are pretty straightforward. Okay, they're just straight across or straight up or straight down. Questions 9 to 13 have funny angles. What do we do when we see a funny angle? Or what do we think when we see a funny angle? 5 words. I don't like funny angles. So fix them. Change it into X's and Y's like we just did. I want to take a look at 2 of the questions from that worksheet from questions 6 through 13. The ones that I want to look at are questions 10. And I also want to look at question, let's make it 13. Question 10 and 13. Question 10 has a vector that looks like this. 60 degrees, and that's 50 meters right there. Okay, what I want to do here is get rid of that funny angle because I don't like funny angles. So I'm going to get rid of that 50 meters at 60 degrees. I want to draw out the triangle, complete the triangle, label this as X, label this as Y. Okay, X is always this way, Y is always this way. So label those, X and Y. X is the opposite side of this triangle, right? Here's my angle right here. Not attached to that or opposite to that is the x-axis. So we're going to say for X, sine 60 degrees is equal to opposite over hypotenuse. How do we know to use sine? Because it's opposite in hypotenuse. If it was cosine, it would have to be adjacent in hypotenuse. 50 times sine 60 is going to give me 43.3, I think. And now we're going to do almost the same thing for the y component, but this time use cosine because the y component is the adjacent side. Cosine 60 is adjacent over hypotenuse. Y ends up being equal to 25 there. How many people got both of those? Good, good. Let's take a look at 13. 13 had a vector that looked like this. We had 30 degrees labeled right here, and we had 80 meters. We want to complete that triangle. Draw a triangle around that. Label this as X and label this as Y. Tell me, please, which side of the triangle, which side of this triangle is X component? Is it opposite or adjacent? Elena? Good. So if it's adjacent and we have hypotenuse, let's use, good, cosine 30 degrees is equal to adjacent over hypotenuse. Notice the last time x was sine, this time x is cosine. You got to do each question on its own and see whether it's sine or cos. Cosine 30 degrees equals x over 80. X would be equal to 69.28 meters. Really, that should be negative, right? How come? Why negative? Because to the left, right? This one went up and to the right. This one went left and down. Okay, let's do the y component. Sine 30 degrees is equal to opposite over hypotenuse. Y ends up being equal to 40 meters. Is that right? Almost, so close. Not 40, but negative 40, because it's down. So, well, what have we really done here, guys? We've changed 50 meters at 60 degrees into this. And this. We've changed 80 meters at 30 degrees into this and this. And that's good news, because we know how to deal with these. It's these that we don't like, right? Now let's put it together. Let's put it all together. We know how to deal with funny angles, right? We say, in our minds at least, I don't like funny angles. And then we get rid of them, change it into an x and a y. But what if we've got a problem where we have, I don't know, let's say a vector like this of 100 meters and another one like this that's 50 meters. Another one that's like this that's maybe, I don't know, let's make it 40 meters. And another one like this, it's, let's say, 100 meters at 30 degrees. What's the goal? What's the goal? Get a right angle triangle, right? It's the first thing you think of here. See this question. I don't care if you know how to do this question right now. What's the first thing you think of when you see the question? 5 words. You got a funny angle, right? 30 degrees. I don't like it. I don't like funny angles. Let's get rid of it. Now, let's go off to the side up here. Let's just redraw it. Here's my 30 degrees. Here's my 100 meters. Here's my x, and here's my y. You see that's the same thing? Guys, you see how that's the same thing? Let's get the x side. Okay? Cosine 30 degrees is equal to adjacent over hypotenuse. And then we're going to say sine 30 degrees is equal to opposite over hypotenuse. Good? That's what we've been doing, right? That's what we did right here. We just changed a funny angle into an x and a y. Look at what I'm about to do. Okay, look up here. Drop your pens for a second. Watch what I'm about to do. That 100 meters, it's dead to me. It's gone, right? It's gone. We killed it. We replace it with 86.6 meters and 50 meters down. See what I just did? Boy, that looks a lot more manageable now, doesn't it? Than it did before when I had that funny angle. If you can do this question right here that you see in front of you right now, but you couldn't do it before I get rid of the funny angle, then just get rid of the funny angle. In other words, do this stuff over here. Guys, you see where that comes from? Do you see how I've done that? All right, what's next? X's and Y's, right? 100 and 0, 0 and negative 50, 40 and 0. What's next? 86.6 and negative 50. See that? This is just like the problems from yesterday now, right? And from Monday. 100 plus 40 plus 86.6 is 226.6. That's a negative 100. Oh, we know how to do this. We got 226.6. We have 100 down. And then our resultant vector, the hypotenuse, is C. Inverse tan of opposite over adjacent. This time it's 100 over 226.6. For C, we get 247.7. And for theta, the side of the room, we get 23.8 degrees. I mean, 23.8 degrees, what of what? South of east, good. Good? Look, we just turned a hard question where we had a funny angle. We just turned it into an easy question by getting rid of the funny angle. Got it? This is such a huge skill to have. I told you guys earlier that we were working on these questions in Physics 30 this morning. Okay? Not in the context of meters, but in the context of electrical forces, stuff that you guys have no idea about. But the analysis is the same thing. Okay, we're just calling them forces instead of distances, that's all. What I'd like you to do right now, guys, please, is work on the remaining questions on that worksheet, questions 14, 15, and 16. Please, especially for 14, 15, 16, please show your work. Okay, please show your work. Whether you have to do it on the back of the page or whether you have a separate piece of paper, that's fine, but please show your work.